Hi guys. Okay, now let's have a look at this question here. It says prove the identity that cosine 2x plus cosine squared x plus 3 sine squared x divided by 2 minus 2 sine squared x equals to 1 over cosine squared x. Okay, now the first thing that I see is this double angle cosine 2x here. Now there's a cosine squared x and there's a sine squared x, so there's no clear indication of which one to change it to, because remember, if I have a double angle cosine 2 theta, then I can write it as cosine squared theta minus sine squared theta, or I can write it as any one of these two in terms of cosine or in terms of sine. But there's no clear indication that I want to change it to sine or cosine, so I am going to go with the original, and I am firstly going to say left hand side and right hand side. I want to prove that this is equals to this, so I'm going to work on my left hand side. So I'm going to go and I'm going to change this, and I'm going to say cosine squared x minus sine squared x plus cosine squared x plus 3 sine squared x. There's no identity here, there's nothing else I can change here, so I just need to rewrite it for now. Divided by 2 minus 2 sine squared x. Okay, now usually I see that this is two terms, and what I want to do if I have two terms is I want to see if I can factorize. Can I factorize? Usually what we do if we factorize, the first thing is take out a common factor. We have a common factor which is 2, so let's take it out. And then 2 divided by 2 is 1 minus sine squared x. Please remember that if I have two terms in the denominator here, I need two terms within my bracket here. Okay, so the next thing that I then see is then that I have cosine squared x plus cosine squared x. So if I add that, I have 2 cosine squared x. The next thing is that I have negative sine squared x plus 3 sine squared x. They are like terms, so I can add them. Minus 1 plus 3 gives me 2. So that's plus 2 sine squared x. And I already see an identity just by looking at this. Okay. Then, next, I have 2 times by 1 minus sine squared x. Now, let's think quickly. 1 minus 2 sine squared theta. It's not the same. Do you guys see? This one has a 2, this one doesn't. So, it's not a double angle. It's not written like this. But think back to grade 11. I can write sine squared theta as 1 minus cosine squared theta. Or I can say cosine squared theta is equals to 1 minus sine squared theta. And isn't this what is written here? So in other words, I can go change this to cosine squared theta. Okay, now the next thing I see is that I have a common factor, is 2, so I'm going to take it out, and then I'm left with cosine squared x plus sine squared x. This is absolutely an extra step, you do not need to show it. Divided by 2 cosine squared x. Okay, now, like I said, it's an extra step, you really do not need to show it. So what I can do is obviously these two are going to cancel. Cosine squared x plus cosine squared x is equal to 1 divided by cosine squared x. The left hand side is equal to the right hand side. And we have proven the identity.